Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. What if I told you there's a planet so big you could fit 1,300 Earths inside it? Not side by side, inside. That planet is Jupiter, the true giant of our solar system. But how big is it really? Could it become a star? And what would happen if it replaced Earth? Tonight, we're diving into the unbelievable scale of the solar system's king. Numbers don't do Jupiter justice. Its diameter is about 143,000 kilometers. That's more than 11 Earths lined up across. But size isn't just width, it's volume. Because Jupiter is a sphere, it has an enormous interior space. When scientists calculate how many Earths could fit inside its volume, they get roughly 1,300 Earths. Imagine shrinking Earth down and pouring it into a giant container. You need over 1,000 copies just to fill Jupiter. And that's why Jupiter contains more than twice the mass of all other planets combined. Jupiter didn't become massive by accident. It formed early in the solar system's history when huge amounts of gas were still floating around the young sun, while smaller rocky planets formed closer in. Jupiter formed farther out where ice existed, gas was abundant, gravity could pull in enormous material. Its strong gravity acted like a cosmic vacuum cleaner, pulling in hydrogen and helium from its surroundings. The result? A gas giant so massive that it almost became something else entirely. A star. People sometimes say Jupiter is a failed star, but is that true? Not exactly. For a planet to ignite into a star, it needs enough mass for its core to start nuclear fusion, the process that powers stars. Jupiter would need about 80 times its current mass to become a true star. That's far beyond anything available in our solar system. So while Jupiter is enormous, it's still nowhere near star-level size. It's more accurate to say, Jupiter is the biggest planet possible without becoming a star. Jupiter isn't like Earth at all. There's no solid surface. If you fell into it, you wouldn't land, you'd sink. Inside Jupiter, upper layer gives thick clouds, middle gives crushing gas atmosphere, deep interior gives liquid metallic hydrogen, core gives possibly rock and ice. The pressure inside gets so intense that hydrogen, the lightest element, turns into a liquid metal. That means Jupiter may literally contain an ocean of metallic hydrogen thousands of kilometers deep. No spacecraft could survive that pressure. Jupiter's atmosphere is one of the most violent places in the solar system. It has winds reaching over 600 kilometers per hour. And its most famous feature? The Great Red Spot, a storm that has been raging for at least 300 years. This storm is so huge. You could fit 2 Earths inside it. That's right. A single storm on Jupiter is larger than our entire planet. Jupiter doesn't just dominate in size. It also has the strongest magnetic field of any planet. Its magnetosphere is so massive it stretches millions of kilometers into space. If humans could see it from Earth, it would appear larger than the moon in the sky. This magnetic field traps deadly radiation, making Jupiter one of the most dangerous places for spacecraft. Even advanced probes can only survive short visits. Despite being dangerous, Jupiter may actually protect us. Its powerful gravity pulls in comets and asteroids that might otherwise hit Earth. Some scientists believe Jupiter acts like a cosmic shield, reducing the number of impacts on inner planets. Without it, Earth might face far more asteroid collisions. In a way, Jupiter might be one reason life on Earth had a chance to evolve. Let's zoom out. If Earth were the size of a grape, Jupiter would be the size of a basketball, and the Sun? A giant beach ball. That's the scale difference we're dealing with. Even though Jupiter could hold 1,300 Earths, it's still tiny compared to a star. So yes, Jupiter really could fit 1,300 Earths inside it. Not because Earth is small, but because Jupiter is unbelievably massive. It's a world of storms larger than planets, oceans of metallic hydrogen, and gravity powerful enough to shape the entire solar system. Beyond the planet itself, Jupiter governs a mini-solar system of its own with nearly 100 known moons. The 4 largest, the Galilean moons, are worlds in their own right. There's Io, the most volcanically active body in the solar system. Then there's Europa, with a hidden ocean under its icy shell that might harbor life. And Ganymede, the largest moon in the solar system, bigger than the planet Mercury. Finally, there's Callisto, a cratered ancient world offering clues about the early solar system. And did you know Jupiter has rings? They're not as famous as Saturn's, but they exist. Made mostly of dust kicked up from its inner moons by micrometeoroid impacts, these faint rings are a subtle, beautiful feature of this gas giant. Our understanding of Jupiter has been revolutionized by NASA's Juno mission. Arriving in 2016, this intrepid probe has been swooping closer to the planet than ever before. Juno has unveiled stunning details about Jupiter's turbulent atmosphere, its mysterious core, and its powerful magnetic field rewriting our textbooks. Jupiter also boasts the most spectacular auroras in the solar system. These curtains of light at its poles are hundreds of times more powerful than Earth's. Finally, Jupiter's role as a cosmic protector was dramatically proven in 1994, when comet Shoemaker-Levy 9 broke apart and slammed into it. The impacts left visible scars larger than Earth, a stunning reminder of the immense forces at play in our solar system. But even Jupiter's most iconic feature is changing. The Great Red Spot, that colossal storm, has been steadily shrinking for over a century. Scientists are racing to understand why this ancient storm is losing its size and what it tells us about the long-term dynamics of Jupiter's atmosphere. Jupiter's gravitational dominance extends far beyond its moons. It has captured thousands of asteroids, known as Trojans, which travel in the same orbit as the planet. These Trojan asteroids are like time capsules from the birth of the solar system, and NASA's Lucy mission is currently on its way to study them up close. And the exploration is far from over. Future missions are already being planned, like NASA's Europa Clipper. This mission will perform dozens of flybys of the icy moon Europa, using its instruments to investigate whether its subsurface ocean has the potential to harbor life. Beyond light, Jupiter also speaks in radio waves. It's the brightest radio source in our sky, second only to the Sun. This powerful radio emission is generated by its immense magnetic field and its interaction with the volcanic moon Io, creating a complex electrical circuit. Scientists also theorize about Jupiter's ancient past. The Grand Tack hypothesis suggests Jupiter migrated dramatically through the early solar system. This journey inward toward the Sun and then back out could have scattered material and dictated the final size and composition of planets like Mars and Earth. And Juno has found more surprises, like the Great Blue Spot. Unlike the Great Red Spot, this isn't a storm but a strange localized anomaly in Jupiter's magnetic field. This feature, concentrated in one hemisphere, challenges our models of how planetary magnetic fields are generated, adding another layer of mystery to the gas giant. And yet, in the grand scale of the universe, even Jupiter is just a speck. If this blew your mind, comment below. Which planet should we explore next? And don't forget to subscribe for more real science about the universe's most incredible wonders.